Okay, so this is the real deal. That if we can do this, everything else is going to be great. Because if we can convert from a mass of a reactant or product to a mass of another reactant or product, that is going to solve a lot of chemistry problems for you. And it's one of the real key skills that you need to be able to take from this course. Just to keep our brains working, Alex is going to make us actually write the equation first. So how do we form ammonium phosphate? It tells us NH4, 3. There's 3 of them because +1 charge against the phosphate, which is a 3- charge. Okay, so you need 3 ammoniums to balance. Is made by reacting phosphoric acid H3PO4 with ammonia NH3. So there is our equation. It is not balanced. Okay, so to balance this one, I'm going to go out and say, first of all, we need 3 nitrogens here. That's a good place to start, right? And then we'll see where we shake up with this, because I can see 4 times 3 is 12 hydrogens. 12 divided by 3 is 4. So it's probably going to be something along the lines of this. Okay, so let's just double check that that is balanced. So 4 times 3 is 12 hydrogens. We've got 4 phosphoruses. We've got 4 times 4 oxygens. That's going to be 16 oxygens. And then we've got 3 nitrogens, but we've also got 3 hydrogens times 3 is 9 hydrogens. Which I've got to add to this 12 hydrogens, so that's going to be 21 hydrogens. That doesn't seem right. What do we do here? I miscalculated this entirely, didn't I? Because I didn't need to do that at all. This is why I shouldn't do things at this time of day. Okay, so let's go back to that 3. So we've got 1, 2, 3, 4. 3 plus 9 is 12 hydrogen. I didn't need to do any of that, did I? Silly me. Right. Anyway, onwards. So what mass of ammonium phosphate is produced by the reaction of 3 grams of ammonia? So let's make a plan. We are going to have to go from the mass of ammonia to the moles of ammonia to the moles of ammonium phosphate. And then when we've got the moles of ammonium phosphate, we can go to the mass of ammonium phosphate. And we've done all these steps individually, right? We just haven't put them together. So you can convert between mass and moles. What do you need? You need your molar mass as your conversion factor, okay? And let's just move this out of the way a little bit. That's not working. And we can convert between moles of one thing and moles of another thing because you just need the mole ratio, right? And say for between the moles of ammonium phosphate and the mass of ammonium phosphate, we're just going to need the molar mass, okay? So the molar mass of, just going to put it up here out of the way, NH3 is going to be nitrogen, which is 14.007 plus 3 times hydrogen, which is 1.007-ish, okay? So I can't read that as well as I thought I could. 14.007 plus 3 times 1.007 gives me a molar mass of about 17.028 grams. Okay. And then my molar mass of my ammonium phosphate, H4, 3PO4. So I've got 3 nitrogens. Oh, it's 14.00674, whatever. 14.007 will do. Times 3. We write this down, shouldn't I? 3 times 14.007 plus how many hydrogens have I got? 12 hydrogens. Plus 12 times 1.007. And then phosphorus is 30.97. And then 4 oxygens. So 4 times 15.9994 equals, did I do that bit? Plus 4 times 15.9994. Okay, I don't recommend putting stuff in your calculator, then writing stuff, then putting stuff in your calculator, because I don't know if I did everything or not now. 149.0720. 6 grams. I'm just going to check that really quickly. Talk amongst yourselves. Plus 12 times 1.07 plus 30.97 plus 4 times 15.994. That's not right either. It's probably fine. It's the principle that matters. Okay, so we now have to do one more thing, which is write our mole ratio between the ammonium and the ammonium phosphate. So we can see it takes 3 moles of ammonia to form 1 mole of ammonium phosphate. Okay, so that mole ratio will be our conversion factor in the middle here. Okay. All right, so to get between mass and moles of ammonia, it's going to be 1 mole of ammonia equals, what did I get for that? 17.028 grams. Okay, so just use the molar mass as an equivalency where that arrow is there. Okay, then to get from moles of ammonia to moles of ammonium phosphate, there's our mole ratio. And then to get from moles of ammonium phosphate to mass of ammonium phosphate, we know that 1 mole of ammonium phosphate weighs exactly, if I could use a calculator, 149.0726 grams. Probably. It's early. I know it's not a molol though. Okay. All right, so that's what we're going to do. Let's just go ahead and execute the plan. Okay, so 3.02 grams of ammonia, convert mass into molar mass. So that's this arrow here is going to become a unit conversion. So 17.028 grams is going to go on the bottom because we want the grams to cancel out, and we'll be left with the units of 1 mole of ammonia. If I press equals right now, but I'm not going to, I'm going to go straight on to get to moles of ammonium phosphate. So my moles of ammonia need to go on the bottom. My moles of ammonium phosphate need to go on the top. So don't worry about the numbers to start with, if that's easier for you. And then I look at my equivalency and I see it's 3 moles of ammonia to every 1 mole of ammonium phosphate. So moles of ammonia will cancel out. I'm here. I've got moles of ammonium phosphate. The last thing I need to do is use the molar mass to get from moles to mass in grams. So the mass in grams is going to go on top, 149.0726 grams probably. 1 mole goes on the bottom. Okay, so you should be able to check that everything is cancelling appropriately with those unit conversions. So grams will cancel, moles of ammonia will cancel. This is why it's always important to write moles of what? Moles of ammonium phosphate will cancel, leaving me with the mass in grams. So let's see if we can work it out. All right, so 3.02 divided by 17.028 divided by 3. This is why it's so important to use that mole ratio rather than being like, do I times by 3 or divide by 3? Well, make sure your units cancel out, and that will take the guesswork out of it. And I end up with 8.81 blah 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 29 blah 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 grams. ALEKS asked for 3 significant digits, so boom boom, there we are. Okay, so we're going to do some more practice of this, okay, just to make sure we've really got the idea. Oh, so quick balance then. So ethanol, CH3, CH2, OH reacts with oxygen to form water and acetic acid, CH3COOH. So that's our equation. Is it balanced? 2 carbons, 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3 oxygens, 1, 2, 3 oxygens. So it's balanced, it's a 1-to-1 ratio, okay, but we're still going to get the idea, okay? So our plan then is we need to go from mass of O2 to moles of O2 to moles of what we were asked for, the ethanol, that's the CH3, CH2, OH, to the mass of ethanol, CH3, CH2, OH. So we're going to need mole ratio, we're going to need molar masses. So the molar mass of oxygen, every 1 mole of O2 is 15.9994 times 2. It's 31.9988 grams. This is how quickly you can do this, okay? From the balanced chemical equation, 1 mole of oxygen is equivalent to 1 mole of CH3, CH2OH, okay? And then the molar mass of that ethanol, 1 mole CH3, CH2OH is, right, carbons, there's 2 of them, so 2 times 12.011 plus, need parentheses, 6 times 1.007 for the hydrogen, and then we've got 1 oxygen, so plus 15.9994 gives me a molar mass of 46.0634 grams. Okay, so let's do it. 1.36 grams of oxygen, 1 mole of oxygen weighs 31.9988 grams. Okay, and then we want to convert moles of oxygen to moles of ethanol. Okay, I know it's 1 to 1. Put it in anyway because we're still converting the units. Okay, get in the habit of doing it every time, and then you won't screw it up by forgetting to do it. Okay, and then finally, we want to convert moles to mass in grams of ethanol. 1 mole CH3 CH2OH. All right, of course, that would have to be just a little bit too long for that. Okay, so let's just check. Grams cancel. Moles of O2 cancel. Moles of ethanol cancel, leaving us to get an answer as a mass in grams. Drum roll, please. Right, 1.36 divided by 31.9988 times 1 times 46.0634 gives me 1.95776 blah 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 grams. 3 significant digits will be 1.96 grams. Okay, so if you don't practice anything else, practice lots and lots of these kind of questions, because if you can do this, you can pretty much do anything that you're required to with Gen Chem 1 in a lot of ways, and Gen Chem 2. Once you learn this, this is your bread and butter, right? This is so important.